So in actual fact, we don't really need the points as an output. What we really want is a curve. So that's really our next step. And just to make this clear, we can keep the points as an output just to check them. Let's call them curve points, and let's call A curve. Well, let's call it what it actually is. Let's call it super ellipse. If we go back in here now, we've got to be careful that we're making a reference to B. Let's just move this into and it's actually now curve points, so we need to use that to get our points to come out. So that's just useful for checking. Okay, so now how do we make a curve here? Now this is where we have to think a little bit more about the structure of our system, and what we're actually doing is we're going to use a part of the Rhino geometry library to build this, and we need to make a new object, a new way of storing these points, a way that we can't get them out, and it's called a point 3D list. We'll give it a name which is PT list, and we have to define this object in the same way. So we say point 3D list, and let's say list, not linced. And right here, so we've got this points object that allows us to see the points coming out, and we've got the now PT list, and if I've set it up correctly, we can add our points to this as well. And we're also, once we've got all those points in that list, we get to the end of the loop, we're going to make a NURBS curve. Now I might have to check, and we'll call it super equals new NURBS curve. Yeah, there we go. So you see here, we put in the bracket, and it starts to tell me what kind of options we've got. Actually here, the way that we need to define it is NURBS curve dot create, and then periodic degree points. So yes, it's true, degree 3, and here this is where we put in our PT list and assign to output parameters. So we called it the super ellipse equals super. Actually here on the periodic, because our points start and end at the same location, we can make this false. So periodic in terms of curves describe whether the curve is closed or not. So because we have one point at the start which corresponds to the same point at the end, we can leave that as false. So hopefully now when I click on OK, we have, you can see here's the curve. Like I said, we don't really need the points, we're more interested in just getting the curve out. And so there's our initial super ellipse. Now we actually need to have a bit more control on this, and so I'm going to do a little bit of editing because I want to be able to control Rx. I'm going to add another parameter which is Ry, and we need to make that parameter also a double. It's giving us an error message, so you can see when we get this red component, we get a little message here. If we click on this, let's just move this across so we can see it. R does not exist, so it's looking for something called R, but I've said actually I want to call my parameters something different because I want to control them independently. So we go back in here. So here we go. We've got R. which no longer exists. I want Rx, Ry. Okay, so that now works. So this now means that we've got a way of controlling our form in a slightly more interesting way. So it's not perfectly symmetrical. And then the other bit of control that I want to add in is I want to be able to shift this curve a little bit in the X direction. So I don't necessarily want it centered on the center of the model space. So I'm going to add one more input parameter. I'm going to call it X shift. I'm going to make it, it's going to be an item still, and it's going to be a double. And then we're going to set that to, let's just, yeah, the value for that, let's just clean this up a little bit, grab those and align them. A good value for that is about minus 26 thousandths. We actually want to shift it to the left. So let's just make a slider, edit that slider, set the minimum to minus 30,000. Okay, that wants to be about minus 26,000. Plug that in there. So now back in the script, we want to think, well, how do we apply that? It's actually very simple. So all we're doing is changing our value for X, and we can just add X shift to it. And if you, here we go, we can just give it a bit of control. I actually don't want to see the points, the curve points coming out. I find it unnecessary. It was good while we were building the function, but now I'm actually going to get rid of those. So let's take out the curve points from here. We're not going to add them to the list, so I want to minimize the work and get rid of this data structure here, and then click OK, and then here I can actually delete that. So here at this point I should save my document. I haven't saved it at all, which is very, very stupid in many ways. So save the document, and we're in volume. I'm going to call it Aviva. Now let's just call this is the super ellipse. So there we've got our first definition of the super ellipse. So now we've got to think about how can we actually take that and start to apply it to make something that looks like the Aviva Stadium.